Greetings and salutations, and thank you for clicking on the video. Today we're going to talk about Linux file types and Linux file permissions. This video is for newcomers to Linux, especially those of you who are coming from the world of Windows. The way Linux handles files is very different than the way the Windows operating system handles its files, and it can be quite confusing for people who are not used to working in a Linux environment. This video probably will be quite tedious for those of you who are already well versed in the ways of Linux, so keep that in mind. I'm going to cover simple concepts and we're going to take a deep dive into this. I have covered these in past videos several times, but usually in concert with a bunch of other concepts that I'm trying to present, like how to use a terminal or talking about the Linux file system in general. I'm going to omit a lot of that stuff today. We're just going to talk about files. That's all we're going to talk about, and how you can interact with them on your system and understand some of the strange error messages you might get when you're trying to do something with your computer. So here are some basic concepts to keep in mind as we roll along. Let's first of all talk about Linux file types. LS with the L option or long option tells you whether a file is a file or a directory, and that's if you're working in a terminal. Of course, if you're working in a graphic user environment, a file manager program, those are usually represented quite simply by different icons. In a graphic user environment, directories are usually represented by a little picture of a manila folder. And the reason why that is because years ago in computer science class, when they were explaining to us the difference between files and directories, they used a filing cabinet as an example. And so therefore they said a file would represent something on a page, a picture or text, and then a directory is like a folder. And you put a bunch of files that you want to group together in a folder, and then you put all the folders and the files in the filing cabinet, and the filing cabinet can hold files and folders. The filing cabinet would represent a storage device like a hard drive. So the word directory and the word folder are interchangeable, but technically speaking, when you're working at a terminal, you would call it a directory, and when you're working in a graphic user environment, you would call it a folder. But I will probably interchange those words as we go through the video, simply because both words apply. Linux does not need extensions to know what's in a file. If you're used to working with Windows, you're used to the concept of a file having a little 3-letter or 4-letter extension on the end that tells you what's in that file. Linux doesn't need that. A file can be called picture, a file can be called song, whatever, and it will know the difference between a JPEG and an MP3. And so when you're working with Linux, especially when you're working in parts of the system that are not user-friendly, like working in the system directories, you're going to see lots of files that don't have any extension, and you're probably going to look at it and go, well, how do I know what it is? We'll tell you how that works as the video rolls on. The file command will tell you what's in a file, and I'll show you how to use that in a little while. Now let's talk about Linux file permissions, because this is really the thing that makes people scratch their heads. The file type thing, yeah, that causes a little bit of dismay, but when they start working with the system, all of these questions come up about file permissions, and I get asked about this all the time, which is the reason why I'm creating this video. This way I can point folks to this video, and then they'll learn everything they need to know. So the first thing to understand about the Linux system is that everything about your computer is represented as a file. Files can contain all kinds of data. I mean, it can be text, it can be pictures, it could be sound, it could be video, whatever. But a file can also represent something like your hard drive or your mouse or your keyboard or your display. And that's how Linux works, because it just looks at everything as being a file, and all the Linux kernel does is move data back and forth from one file to another. It's really that simple. And the reason why Linux works that way is because that's how Unix works. Linux is an operating system that was designed to work alike Unix. It's a work alike. So that means that the Unix system and the Linux system share a lot of the same file structures, file permissions. So if you're watching this video and you ever get stuck in front of a straight Unix machine, you're not going to be lost. It all works the same way. Unix is an old operating system. It's been around for a long time, since the late 60s. That's when they started developing it. And Unix is designed to run on mainframe computers. Big computers that used to fill up a whole room. And those computers could have hundreds of users logged into them at any given time, and each user would have an account on that system. So you got to imagine that a lot of files are being created by a lot of different users, and so therefore you have to have really strong permissions in place to keep everybody's data secure. So every file or directory belongs to someone, which means that every file that's created on the system, it belongs to somebody, whether it be the root user, who is the administrator. That's what we call the administrator in Linux and Unix. They can own a file, or any of the users that have accounts on the computer can own a file. Every file or directory is assigned to a group. A group is a way of taking a bunch of users and giving them all access to the same stuff. Now, today, with the modern Linux systems we use on laptops and desktops, and you might only have 2 or 3 users, or maybe you're the only user on the system, groups don't make a whole lot of sense. But modern Linux systems use groups to figure out what kind of access you have to certain parts of the system. So if you are a Linux user and you're using something that's based on Ubuntu or Linux Mint, you're actually the member of a lot of groups already. When you create a file, it goes into your own personal group. When your account is created, they give you a group that is your username. So files that you create are pretty much automatically owned by you, and they are assigned to your group. Files can be readable, writable, or executable, or any combination of yes or no when it comes to those attributes. A readable file means that you can actually get into it and see the contents. You can display what's in the file. A writable file means that you can modify that, and it also means that you could delete a file. So that gives you the ability to change and save your changes to a file, or remove the file completely. An executable file means that it can be run as a program. You're telling the system that it has code in it that the Linux kernel can read, and then it can actually do something with. For instance, if you're writing scripts for Bash, then Bash looks at that executable and says, oh, there must be code in here I can use, and then it can run it. Directories have to be executable if you want to be able to get into them and create files or do anything with files within a directory. A directory can be readable, which means that you can see it's there, but if it's not executable, you can't actually get into that directory and do anything with those files. So that's something to keep in mind. The executable bit works differently with files and directories. File permissions can be different for owners, groups, and the world. You can have any combination. So you can have a file that only you, the owner, can get into. You can have a file that belongs to you, but it's accessible by another group. So you could have a whole group of users. Let's say that you had a project going and you were working on something, and then everybody could be part of this one group, and then you could create a file and then assign it to that group, and as long as they have access to it in the group, people can work on it. We don't use groups much these days, so it's not something you really have to worry about too much, but it's something to keep in mind. And the last one is the world, which means everybody, all users, anybody that has access to the system. And that's one you really have to watch out for, because if you have those set, that means that anybody anywhere on the system who can navigate to wherever that file is can do something with it. So if you have a file that you absolutely positively don't want anybody to look at or be able to change, then you can turn off file permissions entirely for the world, and then nobody will even know it's there. And finally, the root user or the administrator or the super user, they have complete access to every file on the system. If you are doing something with root user privileges, you can destroy any data that's stored anywhere on the system, and that includes very important critical system files. So when you're doing things as root, you need to proceed very cautiously because file permissions no longer apply. Now that we have the basics down, let's get into actually putting this to work, and let me show you how you can take advantage of this and understand how it's working. We're going to be doing things in a terminal in this part of the video, and the reason why is because I can show you exactly what's going on. If you don't intend on using a terminal when you're working with your Linux system, keep in mind that everything I show you can be done graphically as well, and I'll show you how to do it graphically and in the latter part of the video. So the first thing that we need to do is get some files to look at, and I have created a directory called stuff, and if we list the storage in there, you see that I threw some files in here, and it's all kinds of different files, the kinds that you would come across on your system. So we have some files that are pretty logical. They have extensions that are created by programs, and those extensions tell us what they are. So we have a JPEG, we have a GIF, we've got an MP3, we got a text file, we've got a document file. That's my French onion soup recipe there. And then we got some files that don't have any extensions on them. And we have color coding that kind of tells us what they are, but we still don't know. So if you want to know more about what you're looking at in a directory, the best way to do that is to just list it with the L option. And now we're going to get a lot of information about these files. So the first part here might look like complete gobbledygook, and we're talking about right here, but this is actually a bunch of important information right here. And to figure out what's in there, let's jump over here and look at this graphic. So what we're looking at is the permissions bit on the file, that actual information. And the first thing that we have is a dash, and if we come down here where the arrow points and look, we see that that indicates a regular file. Just a dash means it's a regular file. It's not a special file. It's not a directory. If you see a D there, that means it's a directory. If you see an L there, that means it's a link. Now, there are other file types, but you are not going to come across them in your home folder. It's just not going to happen. They're going to be in the system. So, specialized file types that represent devices, they have special different flags there that come up. But like I said, as an average user, you're not going to see that very often. Then we have the permissions of the file, and it's 3 groups of 3 right here. So the first group of 3 represents the owner. That's you. All right. You can read, write, and execute on this file. So if you can read it, it's got an R. The W, it means that you can write to it, and execute means that you can execute. The next group is for, the next group of 3 represents the group. And the next group of 3, the last one, represents the world. And remember, this one's very important because anybody that can have access to your file, in this case, is going to be able to read that file. They're not going to be able to change it. They're not going to be able to delete it, but they are going to have access to its contents. So that's how those permissions work. So the next thing that you see on the list here is this number. And this is, you can just pretty much ignore this because all it is links. This is the links to the file, the number of links, which is not something that the average user really needs to worry about too much, but it does show you. So most files will have a link of 1 because there's only one file there, but if you can have more links to a file, you can have a file appear in other parts of the file system. In that case, you would see more links. Here we get the owner and the group. These are the people that own the file, and the group it is assigned to. And in this case, most of the files in here are assigned to me, since my username is Joe and my group is Joe. But we do have one that's assigned to somebody else. This is Cindy's file right here. This is the file size, and it shows it in kilobytes, 1024K blocks actually, and it's semi-useless that way, but there's a way to fix that if you're looking here. Just add an H to this listing, and now we get humanly readable sizes on the text there. So that's a little tip to keep in mind. And then over here we've got the modification date. If the file was modified more than a year ago, then we get the day and the year of its last modification. So this Billy Joel Big Shot MP3, I've had it since 2009, and it has not been modified since then. Okay, we have one here from 2004, and so on. So we got some pretty old files in here. And it looks like I came up with my French onion soup recipe in 2010. If it's a file that's been created within the last year, then it gives you the date, and it'll give you the time that the file was created. So that's the difference there. And then finally here we get the file name. Now we can look at this and see that we have a bunch of regular files. We have one link here. This is a link to a picture called permissions, and then it links to another file somewhere else in the system, and it is called permissions diagram.gif or GIF or whatever you want to call that. And so there you go. But we're still having a hard time figuring out what some of these files are. So we have a file that's called text, but it might be called something else. If it's called text, we kind of know it's text. So let's see what we got here. We can use the file command and then put in text. Now the system will tell us down here at the bottom of the screen that this is an ASCII text file with no line terminators. And what that's telling you is that the text in this file is just a big long string of words and spaces. There are no carriage returns in that, and that's because that file was probably created on a Windows system. Or it just doesn't have it. So let's look at some other things here. We already know what it is because a lot of these files were created by programs that automatically put the extensions on there for the convenience of looking at what they are. And also, if you're going to share files with a Windows system, it's nice to have an extension so they know what it is. But let's just do it anyway. So let's do file, and we'll look at Billy Joel here. Oop. There we go. And it's telling us that this is an MP3 file, and let's look at another one here. Let's look at our picture of Beaker. No, there you go. So that's how you can look at a file and go, I don't quite know what that is. Let's see what it is. Let's try it on one more. Well, now it says that this is a shell script. Okay, if we look up here at the permissions for Syncit, that's an executable file, which means that that's actually a program. Pretty cool, huh? So let's clear the screen and see what else we can do here. Well, I wanted to type ls. Thank you. All right, now it makes sense. So we have our files here. So what can we do with them? Well, let's talk first of all about changing file permissions. As a user, you have the ability to change file permissions on files that you own. So if you want to tailor the file permissions for a particular file for whatever reason, there's a couple of ways that you can do that. You can do that from a GUI or a graphic user interface. You can do that from a file manager, or you can do it from a terminal. I prefer to work with permissions at a terminal because you can use wildcards, and you can do a whole bunch of files, or you can do one file. You can do all kinds of things. So I'm going to show you how to do that, and I'm going to show you this command, which is change mode, but with no E. So it's change mode with no E, or change mod, however you want to say that. But it's mode, that's what it's supposed to be. And then there are a couple of ways to make this command work for us. So let us try to make the file called text executable and see what happens. There's a symbolic way to pass information to the change mode command, which involves using letters and pluses and minuses. It's sort of like the attribute command or the attrib command in Windows. If you've ever played around with that, if you remember that from the days of DOS, it's kind of the same sort of system. I find it to be very confusing. The only time that I ever use the symbolic method is to make a file executable, because if I'm going to make a file executable, I just make it executable across the board. So to do that, I would use the plus sign, and then we would say plus X, and then when we give it our file name, in this case we're going to do text, and then we turn it loose. Oops, we have an error, and this is one that you're going to run into. Why can't I do that? It says, well, the program is change mod, and it says changing permissions of the file called text, and then it tells us that the operation is not permitted. Well, why is the operation not permitted? Let's list that file again and see what's going on. So we'll do LSL, and we'll do text. Oh, that file is owned by Cindy. I don't have permissions to work on that file. Looks to me, since I am not in a group called Cindy and the file is owned by Cindy, that the world permissions on this file will only allow me to read it. So there's a couple of things that I can do here. I could change the ownership of the file using a command called change own, and I could make that file be any, I could make it my file or I could give it to somebody else. But what if I am a user on a system and I do not have administrator privileges, but I got to do something with this file? I need this information. How am I going to get it? Well, since I have read permissions, that means I can copy the file. So let's just copy it. And we're going to put this file, it's the copy text, and we're going to put it into a file called Joe-text. All right. So we should be able to get a copy of it. Okay, let's just make sure it made it. Yep, it's there. So now what I should be able to do is do what we started to do, and that's change the permissions and make this executable. So let's go back up here to our command, and we'll just give it a different file name. Well, that was successful. So let's ls, and we'll do a long listing again. And we'll look for our file called Joe-text. There it is, and you see that that is now executable. So what if you do have privileges like that and you want to be able to give the file to another user? So this is a concept, this is also how you would change what group a file is assigned to. So let's look at that command real quick. So let's just take the file text, and I'm going to change it to owned by me. So we would use sudo to get root privileges and act as the root user. And then we would do change own. And then we would tell it that I want this file to belong to me. Use a colon. And then I would say I want this file to be in my group as well. And then I'll give it a file name, text. So now when I issue this command, it's going to ask me for administrator privileges, and now that has been done. So let's see. There we go. So now that file, well, you can't see that. Let's do LSL -L. Thank you. Now we got it. All right. And you see now the file belongs to me. It no longer belongs to Cindy. And that's the basics of changing file permissions symbolically and changing the owners. Now, I said that the symbolic method for changing file permissions, I really have never gotten into it. If you want to know more about how that works, then what you can do is run man and then change mod here, change mode, and it will show you what it is. How about typing that in correctly? Thank you. What am I doing wrong? Oh, I see. There we go. Thank you. And this will tell you all about how to use that command. This is how I use it. This is the easiest way for me to do it. We're going to look at the symbolic. We talked about symbolic, but we haven't showed you how to use it. It confuses me. I go crazy. I use the octal method. What does that mean? So let's jump into that real quick. Go ahead and get to this different picture here. The Linux permissions are stored in they're stored in 3 bytes of data at the beginning of the file, and a byte of data represents 8 bits. When we use the octal method to represent data, and this would be like ASCII text or numbers or something like that, we really only use 7 of those bits. So the information about the permissions stored in those bytes is all numeric, and we can use just real simple math to be able to represent those permissions. So let's look here at user, and you'll see that the read permission equals 4, and the write permission equals 2, and then the execute permission equals 1. So in this instance right here, this particular file has all the permissions set to on. So, and all of the permissions added together equals 7. Now I know in past videos I said it's a byte of data, but we're only using 7 bits, and I confused some people and they thought that I was saying, well, a byte is 7 bits. No, it's not. We just used 7, or rather that a byte was 7 bits and not 8 bits, and that confused some people. This is the correct way to do this. Yes, it's 8 bits of data. A byte is 8 bits, but we're only using 7 to represent what we're talking about here. So just make sure that that's completely clear so nobody puts in the comments, well, a byte's 8 bits. I know that. Okay, so how do we use this in practice? Let's go back to our files here, and I'll just do a regular ls, and let's say that we wanted to change the permission of Joe text. So the first thing that we want to do is take a look at what the permissions are set at. So that would be ls, l, joe, autofill, and currently this file is set to execute. I don't want this file to be executable. Let's say that I want this file to be readable and writable by me, but nobody else can actually see the file. So once again, we do change mode, and this time I'm going to put in numbers. So if I want the file to be readable and writable but not executable, that equals 6. If I want the file for the group to be just readable, that equals 4. If I want the file for everybody else on the computer to be completely inaccessible, they can't read it, they can't write it, they can't do anything with it, that would be 0. Now we'll give it the name of the file to work with. So let's ls-l that file, and now you see that we have those permissions set that way. You may see this command done with 4 characters. So let's do that one more time, because sometimes in some documentation you'll see this. Let's go back over here. I'm going to put an O in front. And just to show that it changed something, we're going to make this file readable by everybody in the world. So now we have 0644. Now I'm going to issue the command, and we'll list it again. Now look, see, it's readable to everyone. Well, what's that first character for, that 0 there? That's if you are going to assign a special file type to a file. That's what that represents. In this case, we put a 0 in, which means that, hey, we are going to just leave the file as a regular file. We're not going to do anything special to it. So in normal practice, just doing the command this way works just fine, but with 3 characters, that's what I wanted to show you. But to be absolutely technically perfect about it, you'd put a character up front. So if you see that, that's what that comes from, but in normal practice, just doing 3 characters is just fine. And you can do that with a bunch of wildcard files. So let's do that with the text files on the system. I'll show you how to do it with a wildcard. So we'll list the storage, and this time around we're just going to look at everything that has the extension text on it. So we use the glob there, and now we're listing just things that have the extension text. And right now we only have 1 file that has that extension on it, don't we? Thought there was more in there. So let's see here. I guess we need to add text to the end of a file. So let's do this. Let us move text to text.txt. And now we're going to list those again. Now you see we get 2 files. So if I want to change the permission on both those files, how would I do that? And well, what you would do is come back up here, and we will change this to dot, or rather a glob or a asterisk or whatever you want to call that thing, text star txt. Now every file in the system that is text. Did that to the wrong command. Let's just type that in. Let's say we're going to make this one, we'll just for fun make them executable, but nobody else can get to them, just so we see that they change. Okay, so now what the system's going to do is it's going to apply this to those two files. Did it do it? And we'll do, let's just do star.txt again. Now you see that those permissions have all changed. So that's how I do it when I'm working at a directory. So that's it, gang. That's really all you need to know about changing file permissions. That it's really that simple. But the rules are rigidly enforced. And that's something that you have to keep in mind. So as you're moving through working on the system like this, you might find that you get those sort of errors. Those are permission errors, and that's why you can't access stuff on the system that way. Now that we've gone through all that stuff in the terminal, let's look at how you do it in the file manager in a Linux system. And today we're looking at Linux Mint with Nemo. Nemo is one of my favorite file managers. It has a lot of really cool features in it. And depending on what distribution you are running, you may or may not have some of these features. In Ubuntu, the default file manager is called Nautilus. It doesn't have a lot of, it's pretty stripped down, it doesn't have a lot of features. If you are running the Mate or Mate desktop, however you want to say that, then you are going to have the Kaha file manager. That's pretty well featured. If you're running, for instance, the XFCE desktop, then your file manager will probably be Thunar. For KDE desktop, you're going to be using Dolphin and so on and so on. But file managers are file managers are file managers, and the basics remain the same. So we're going to look at how we do all the stuff that we did in the terminal in the file manager. Well, the first thing that you can see is that we can pretty much figure out what the file types are just by looking at the screen, because Linux has figured out what they are, and it assigns an icon to things that might be an icon for a program that opens it. In this case, this is an audio file, so we get a musical note, and then this is a picture, so obviously we have a picture there, and so forth. And even this particular one, which is actually a link, we get to see the picture that it links to. So you can dig deeper into file types simply by telling it that you want to make a list of the files instead of looking at icons. And over here in this column, it tells us exactly what we're looking at. That's a folder, that's an image, this is audio, this is text, and it will even identify that Syncit is an executable program. So that is pretty cool. File types pretty much well taken care of in the file manager, and you don't have to worry about that sort of thing. So how do we change file permissions on a file? Well, let's see. What file permissions did we leave on this? We will do a right click, and then we will choose properties, and then go to permissions. And now we see all the permissions that we have set. And the last time around, I said that people could read and write it, but nobody else had access to it. Not even people who are a member of the group Joe. So what if we want to change that? No big deal. Just change that to read and write. And then we'll just change this to none. That way the world has none. If we wanted to make it executable, we would just click there, and that's it. We have changed the permissions on that file. Now the one thing that we can't change here is the owner, because we don't have permission to do that. I'm running as a standard user right now. So if I wanted to change the owner, then I would have to log in. I would actually have to run this program as a root user. And I'll show you how to do that in just a second. These are the groups that I belong to. I can assign this file to any group that I belong to. Now these are system control groups right here. You really don't want your files to be owned by system control groups in Ubuntu-based Linux like Linux Mint. But if I was a member of a group, let's say called Development Project, something crazy like that, then I could say this file would be accessible by anybody who's a member of that group. And this is where I would set that here. Most of the time you just leave that alone. So if we wanted to change the owner of a file, well, the quickest and dirtiest and easiest way to do that is to copy the file to that owner. So let's say that I wanted to jump over into, let's open up, let's do this here. Let's split screen this. And then over here in this one, okay, we'll just go over here like this. Let's go to File System. And then we're going to jump into the home directory, which is already highlighted. Then I can jump into Cindy's. And let's say that I wanted to grab a picture out of Cindy's stuff. Okay, just anything will do. Let's get a picture of Carly the dog. Okay, and if I wanted to make a copy of that, obviously, because I can see these files, I have read access to them. And if I can read it, then I can copy it like this. Now I have a copy of that picture. So if I look at the properties on the original file, let us, no, I don't want to compress. I want to look at the properties, and we go to permissions. You'll see that it's owned by Cindy, and there you go. So if I look at my copy that I just made, we do the same thing here. You see, this one is owned by me. And that's because I copied it over. And when the system created the file in my home folder, it used the default settings to create it with the permissions that it would have if I created the file myself. But what if I really do need to change the ownership of a file? Let's say that I want somebody to be able to navigate to my home folder and grab a file or directory full of stuff and drag it over to them. They can actually come get it, and there you go. How would I do that? Well, in this case, I'm going to have to change the owner. So let's just go ahead and look at my directory here. And then I'm going to open this directory in a terminal. And now what we need to do is get Nemo running as an administrator. And we do that by doing sudo Nemo. It's going to ask for a password. Make sure we can do this. And now we get a different window, and look, we have a warning message up here that says, we're running this as an administrator. And it's opened up to my home folder here. And so now we can change the ownership of a file. So let's just go back into this picture of Carly, and we'll do properties. I go to permissions. Now you see that I can choose the owner here. So let's do that. And you'll see that there are actually a lot of users on your system. These are system users. This isn't, what you're looking at here is a bunch of system type users. So you'll need to scroll to find Cindy here. So now we're going to make this file Cindy's, and we're going to put it in the group Cindy as well. Now, instead of just seeing groups that we belong to, look at this. There are all of the groups on the system. So if we want to put it in the user group, that's fine. And we're going to leave the permissions as they are. Read and write, and read only for group, and read for the world. And then we will close. Now, if we look at the properties again, just to make sure here, I'm just kind of belaboring a point, we see that that is Cindy's file. Guess what? I'm not going to be able to delete that. Well, I can do it here in the root Nautilus, but let's get out of this. We've made our change. So I want to prove something here that I'm going to go ahead and close that terminal. Yes. Now let me try and delete this file. It let me delete it. Let's see if it put it in the trash. Yep, it put it in the trash. So it will let me delete the file. Restore deleted items. Let's see if I can open the file. Yes, I can do that. It's owned by Cindy. Let's see if I can permanently delete the file. Well, it will let me delete files. I was thinking that it wouldn't, so I just found out something myself because I figured that I couldn't delete a file. I guess maybe it's because it's in my own home folder, and it figures if it's in my home folder and I want to get rid of it, I can do it. But if I was doing that in a terminal and I was doing it in Cindy's home folder, I couldn't do it. Like, there's no way that I could delete a file in Cindy's. So let's just go to File System. We go to Home, and we'll go to Cindy, and we'll go to Pictures, and let's see, we'll just try and delete this one. Nope, it's not going to let me do it. Nope, I can't even activate that command because it's not in my home folder. And I do not have the permissions to be able to delete files in my home folder. So there you go. That's how that works, gang. Now, here's another thing that I need to point out. You can move files around on the system, and if you do it as the super user, what's going to happen is that you are going to create the copy of the file as the super user, which means it will have root permissions only. So let's do this. Let's get into stuff again. Oh, it's got to be a capital T. All right, so we'll just list the storage here. And let's just make a copy of a file as root. So I'm going to do sudo cp, and we will copy joe.txt. And we'll just make this file 2. So let's go ahead and do that. But I'm doing it as the root user. So now, give it my password. I've made my copy. Let's do an ls with the long option. And look, this file is now owned by root. This file 2 right here. I shouldn't be able to remove this with normal privileges. So let's go ahead and try that, file 2. This is just a remove command. See if it'll take it out of the system. Nope. File is write protected, and I'm not going to be able to do that. But it is prompting me to go ahead and remove it. That is because when you're fooling around with permissions and things like that, it is quite possible for you to create a file with the wrong owner and the wrong permissions that you yourself can't delete. Linux knows this, so now it's going to go ahead and let me delete this file. And that's because I'm doing it within my own file system. If I try to do this in the root file system, I may just get told no, you can't delete this file. And the only way I'd be able to do that is to do it as the super user. But since we're within our own home directory here, the system kind of is helping us out. It's going, do you really want to do this? And I'm going to tell it yes. And then we'll just run that command again. And now you see that file is gone. So that's how file permissions work in Linux and Unix. And I certainly hope that this has helped to clear the air for some of you who have a hard time dealing with the concept of file permissions. It's one of the features that makes Linux and Unix very secure in a networked environment, like being on the internet. And it's a big difference from other systems. So pretty cool knowledge to have in your back pocket. One final note about file permissions. You might hear the concept of a Umask being tossed around in different forums. The Umask is what your distribution uses to actually set a default file permission scheme for users. And as a user, you have access to your Umask, and you can have the system create files by default with whatever kind of permissions that you want. So for instance, if you are running in a situation where you need really high security and you do not want to share files with anybody else on the system, you can set your Umask to create files that give the world absolutely no access at all. There's an article about how to do this in Ubuntu and Linux Mint, and it is right here. Actually, this probably would refer more to Ubuntu. I would suggest that if you wanted to change the Umask in Linux Mint, that you look up how they do it because they do it differently. Ubuntu automatically creates files that have read and write permissions set on both the owner and the user. Or rather the owner and the group, I'll get it straight sooner or later. And Linux Mint, by default, sets its permissions to give the owner read and write access and the group only read access. So it is a little bit different between the two distributions, and each distribution of Linux may do it in a slightly different way, exactly where they store the Umask information. So if you want to do it in Ubuntu, I will go ahead and link this article in the description since I'm showing it. But if you're doing it on another distribution, then I would suggest doing a search for change Umask in Linux Mint, change Umask in Fedora, change Umask in Arch Linux, so that you make sure that you get it correct. So, thank you for watching the video. I hope this helped. And please be sure and check out Easy Linux on the web. Check out Easy Linux on Facebook. And check out freedompenguin.com for lots of cool stories about Linux. The wallpaper that you saw in this video is available at the Easy Linux site. It is linked in the description to the video. Just go to the Easy Linux site and then go to wallpapers, and you can snag that for yourself. People always ask about wallpapers, so that's why I'm putting that in there. Thank you very much for watching. We will do it again soon.